Hey everyone, thank you so much once again for joining me today. This will be a quick 15-minute lightning session. I'm going to talk about openness and open lakehouse architecture a little bit here. My name is Dipankar, and I lead developer relations here at Cloudera. My background has been mostly into open source technologies, mostly focused on Lakehouse. Very early contributions to Apache Iceberg, then Apache Hudi, Xstable, Apache Arrow as well. And I've been lucky enough to publish some of this foundational educational materials around like the Lakehouse ecosystem. These are my books. If you can scan the QR code, you will probably like end up in the source of it. But okay, so there is a lot of buzz around Lakehouse architecture nowadays, right? And a lot of momentum, which is amazing to see. And three projects in Apache Iceberg, Hudi, and Delta Lake, they have been primarily at the center. And these two open table formats have kind of changed the way organizations think of building their data architecture today, right? And most importantly, the important part here is that it has forced data vendors to think a little bit more about how they can allow their customers to make data more interoperable with any kind of compute in their environment, right? And also, just to mention some of the newer table formats like DuckLake and Lance that have come out recently and building so many cool stuff. All right. The thing is, table format is not the only component that you typically see in an open lakehouse architecture, right? And an open lakehouse actually has like other things like the file format, the storage engine. There's the catalog compute along with the table format thing, and we're going to go over some of these things very quickly. But unfortunately, in the marketing lingo and in the market, we use the term open table format and open lakehouse very interchangeably. So the way it looks like from a 10,000 feet is you suddenly replace your proprietary storage like a data warehouse with an open table format like Iceberg, and everything becomes open, right? Well, in reality, that's not the case, and we will go over some of these nuances today, especially kind of like trying to like figure out the differences between the open table format versus the open lakehouse architecture. So to answer this, let's quickly walk through how the architecture has evolved over the period of time, right? And so we can understand what openness has meant over a period of time. Starting with OLTP systems, on the left, these are obviously your traditional relational databases. And if you break down an OLTP system, you will find the key components like storage, file format, table format, storage engine, the catalog, and all of these things are tightly bundled into one single system, right? Now, moving to the OLAP system or data warehouses world, which were primarily for analytical workload, you will see the exact similar component, right? The only difference is probably like the file format has changed from row to columnar, but again, everything remains bundled. And that bundling is critical because it means formats are proprietary and tightly coupled to a specific compute engine, right? So once your data is inside those data systems, you're kind of locked into that system, which was only accessible within their own compute, right? And I'm so happy to see this image changing in the recent times, which is really amazing to think of, right? So then came the era of data lakes, and primarily they addressed two things. One was the cost, and other was the flexibility with working, with different type of data types like structured, semi-structured, unstructured. And data lakes introduce open file formats like Parquet, ORC, Avro. And the key architectural separation was like the separation of storage and compute. But also there was no table format or storage engine in a data lake, right? Which meant no asset guarantees, no transaction, and those kind of capabilities were kind of missing. So this is where your lakehouse comes in, and without spending much time, a lakehouse basically combines the strengths of a data warehouse and the data lakes, right? So you bring transactional capabilities onto low cost scalable lake storage, right? So what that means is you now get things like time travel, schema evolution, indexing, performance optimization, but on top of those open file and table formats, right? Um, I would like to mention here that the key takeaway though is that in a lakehouse architecture, all of this component that you see here are not bundled into one single system, right? In fact, their nature is more modular, right? Which means your data sits in this open file and table format foundation, so the data remains open, and you have the flexibility as a customer to bring in your set of compute, your catalog tool, your storage engine, or whatever it is, right? So that's the flexibility you get with the lakehouse architecture. And this is the reason why openness becomes so critical in this lakehouse architecture, right? All right. This is a paper I published some time back, just so if you're curious and want to learn a little bit more about data lakehouses. But just going over the stack overall, right? Just quickly, in the bottom you have the data lake storage, and this is where your all the data lands, from your transactional system. Maybe it has been ingested by a ETL process, and it can contain any kind of file, right? So in a more technical sense, it's a way of taking the bytes, combining them into a file, and saving them into a designated path in the file system. That's what we basically do. And there are different vendors, of course, like S3, but are also open source projects like Apache Ozone. Next is the file format. The file format is where your actual data is being written, right? Those bytes are basically stored, right? And these are columnar or row fashion, depending on the nature of workloads. But again, why you need your file format to be open is because this is where your actual data resides, right? The data files. So it's very important that you think of this as an open layer as well. The next is obviously the open table format, which is really the foundation of a lakehouse. And just to go a little bit of towards the history of things, the idea of table isn't really new, right? We have had that in like SQL databases, right, from different vendors. In the data lakes, we had files like Parquet, but we were missing that abstraction, right? That database level abstraction. And then table formats like Apache Hive, which kind of like opened a new era for open table format. But they kind of made data accessible through SQL to data analysts, data scientists, right? And it was not just confined to a certain set of specialized engineers, right? The problem is these don't just organize file, right? The newer table formats like Iceberg, Hudi, and Delta Lake, they bring the schema management capabilities, things like partitioning, statistics. All of this comes together very well with the lakehouse architecture, and the table format brings all of this together. There is another important component, the storage engine. This is basically like, think of it like your database cleaner, how your storage is being optimized, how your indexes are maintained. All of these things are being taken care by storage engine. And it is very important that you keep this thing open as well. Finally, moving more to upper layers, the compute engine is obviously the processing part, the transformation part, right? And this is where your Spark for distributed ETL, or Flink for streaming, Trino or DuckDB for kind of ad hoc single node workloads as well. But you have the flexibility to really plug in any kind of compute that you want in a Lakehouse architecture because of the foundation that is set by the table format and the file format and the ecosystem around it, right? So that's the prime takeaway from this. The catalog layer is another important piece of the puzzle, right? Because it's kind of becoming an important angle, because all of the governance angle, the who should have access, what kind of access is important, right? Whether it's role based, different type of sorts are being happening in the catalog world. I would highly suggest following those routes. But it's important that the catalog layer it doesn't get hold on into like a particular vendor set. Now, coming back to the core question, all right, which is what's the difference between an open table format and an open lakehouse architecture? Well, an open table format like Iceberg, Hudi, or Delta Lake isn't just one component. It acts as a metadata layer on top of the file format, right? It creates kind of an open data tier that multiple engines can read and write to. But a lakehouse is actually much more broader, right? It includes the table format, it includes the file format, the storage engine, and so all of these things work together, right? And so the distinction becomes important as you move towards your production journey, because that's where these choices across this component makes a lot more sense, right? So the key takeaway is simple. A table format enables openness at a data layer, and a lakehouse architecture defines how this entire system works together. Okay. So to wrap this up, open table data architecture isn't just about one component, as we have realized in this kind of like quicker version of the talk. It's about the entire stack staying open and interoperable. And there are four key requirements that I typically feel you should think about as you're evaluating vendor platforms, right? One, open standards across open components, right? So not just open source, you should have a flexibility. Let's say you go with a particular vendor platform, you should have the flexibility to bring in the tools as you would want, or switch to something else if something doesn't work out down the line. The second point is interoperability at the storage layer, which is your data should remain accessible across format, across tools and engine, right? Not tied to one. And this is where we have to think a little bit about the newer file formats and table formats coming in, right? How do we make them interoperable? The third point is interoperability between catalogs. Like I said, you have to make sure your catalogs are not locked into a particular vendor platform, but it follows standards like the Iceberg REST specification, right? Which is a great example to think about, where different tools and platform can come together and interact with the Iceberg tables. And finally, the open table services, which are super important for maintaining your platform. So if you get this right, you don't have a lakehouse, you have a truly open data architecture, and that's kind of the vision. So thank you so much for having me. If you are interested in like these kind of talks and blogs that I write and kind of publish, you should join the Cloudera community. Here is a QR code for that, and I'm open to any questions here. All right. I can't hear you, Adam. I think probably you're muted.
This was absolutely fascinating. This
All
was
right, that was a quick
incredible.
one. Yeah.
Yeah. Thank you very much. I mean, like it just inspires so many thoughts and questions. And I mean, it's just walking through the history of these developments. I mean, we don't often do this, and you just
Right.
gave us a little bit of like a taste of sort of like the joy of exploring it from that angle. Okay, well, we have a couple of questions,
Hmm.
and otherwise, I might just try to ask you some more myself. Okay, we
Yes.
have one, and folks, if you do have more questions, please put them in the Q&A session, and otherwise, you can also upvote the ones that you would like to see on the stage. So, our first one: will you recommend open table format for your AI model training or a more defined table format? In which scenario will you choose either or?
Great question. And this is where I also like casually mention, like newer formats coming in, right? The
Mhm.
way to think about this is that the open table format revolution has enabled us to like be more open. And as we think about like agentic workflows like MCPs and different access to tools and platform, right? So I think there are newer table formats like Lance is an honorary mention here. That's there. But I would like to mention that Iceberg, for example, like as a table format, or Hudi, for example, as a table format, are natively bringing a lot of this vector embeddings features and a lot of like the things in the AI world that you typically need as primitives, like more of like column, like higher level of columns or like higher dimensional columns. Those are coming natively to these table formats. So I would say yes, open table format would be a great addition for even like kind of feature training, for model training, and even at the level of like when you are making data accessible to your agentic workflows.
Awesome. Okay. Thank you very much for that. We have a couple of other questions. We're going to go through them
Mhm.
fairly quickly. So let's bring this one on. So, yeah, this is interesting. What would you call a closed or partially closed system? And do you have any
Yeah.
examples of that?
Yeah, I would not name names because of the controversial angle of things, but definitely, I would like I said, the 4 points that I mentioned, right, in terms of what you need to evaluate for openness. So think about a platform, that doesn't allow you to switch. Like let's say you're using a particular compute, and it doesn't allow you to move from that particular compute, without bringing in the different nuances that you would need to. I think that's kind of a red flag in terms of like what you're calling it open or closed, right? Think about, let's say, you have a iceberg rest specification that you've implemented as a catalog for your own like vendor platform, right? Now if you are only enabling users to read from that particular table and not enabling like multi-directional operational like writes and stuff, I think that's something to really think about. So I would like think more about the tenants that you need to like evaluate, like more of the storage part, the catalog part, the interoperability in the table management services. Those are some of the things that you need to think about initially, like just so you are not getting trapped in any form of way.
Cool. Okay. Dipankar, I'm going to serve you maybe one or two more
Mhm. Bring it on.
questions. We got this one from
Oh,
Alexander. What would be the paper that you write? And can
right.
you
Yeah.
share the link?
It's called Data Lakehouse. I'm gonna share the link here.
Yeah, if you can put it in the chat.
Yeah, if you even like Google like Data Lakehouse paper. Okay, I got it. There we go. All right. So maybe I'll just put it here. There we go. Yeah, it's a
Nice.
it's a paper that touches on like when I was starting my journey myself coming in from different database system, I was like, how does a lakehouse work? Does it
Mm,
even compare to a data warehouse or database system? So it's really a comparative angle to this different system because I was like in my mind, I need to understand the systems from from that angle and not just from a marketing point of view, right? So that was the whole goal.
awesome. Okay, let's see if we have any other ones here for you. What optimizations are being done to maintain the huge metadata at the Iceberg table format?
Amazing. Yeah. I'm assuming like people who ask this question about metadata and iceberg, I know they have felt the pain in some way about managing metadata, because this was actually one of the hottest topic in the iceberg summit that I just came back from like in a
Mm,
couple of weeks back. But basically, there's a lot of work going on right now with the V4 spec of iceberg that I can say. One is we are replacing, kind of proposing replacing this kind of like bigger metadata tree into the single file or reduced commit structure. So which means right now, if we make a smaller change as a commit, you have to rewrite that entire tree right now, right? Which leads to a lot of metadata file generation. The idea right now with the proposal is that we make a reduced file commit so that it's not too many metadata file. So even for like low latency streaming based, right? Like for Flink, we can take benefit of that. The second part towards that is like we are also thinking about implementing like and migrating towards like using Parquet as manifest files instead of like Avro, and because that gives us like columnar based statistics, which allows like query engines to even like prune data metadata in a better way. So I think those are some of the things that we have been thinking.
Awesome. Okay, Dipankar, thank you very much.
All right, thank you
Stick
so much for having
around
me.
in the chat for some more questions
Absolutely.
that folks might have, and everybody who contributed to those questions. I appreciate that as well, and whoever is given some upvotes too. That's we want to see the love to these questions, and that helps us to pick them. So Dipankar, thank you very much.
Thank you
I
so
have
much.
a feeling we're going to see more of you because I have so many ideas and questions, and just
Amazing. Yeah,
walking
let's
through the
connect. Yeah,
history of this is absolutely fascinating.
awesome,
So
awesome. Right, have a good one.
thank you very much, Dipankar.
Bye.
We were going.